the diagram shows a triangle OAB in which angle OAB is equal to 90 degrees and A is equal to 5 centimeters. So let's pause there and let's interpret that statement. What is the statement told us? This is a right angled triangle. This is a right angled triangle. So every time, we've done this in the previous two videos, every time you see a right angled triangle, just think about Pythagoras and think about SOHCAHTOA. Okay? Think about SOHCAHTOA. Okay? Anytime you see a right angled triangle, the first thing that should come to your head, apart from Pythagoras, is SOHCAHTOA. Sine is equal to opposite of a hypotenuse, cosine is equal to adjacent of a hypotenuse, tangent is equal to opposite of a adjacent. Just think about SOHCAHTOA. This is a right angled triangle, and I've drawn it over here. The arc AC is part of a circle with center O. Let's pause there. The arc AC is part of a circle with center O. What has this statement really told us? This is a sector. OAC is a sector. OCA, ACO, AOC, or however you look at it. This thing here where my cursor is moving to, this is a sector. This is a sector and it's part of a circle. This is a sector. And what is the radius of the sector? It's 5. Remember that this arc here, if this arc is a part of the circle, what tells you is that this arc here is part of the circumference of a circle. Remember, like I said, read the question and try to understand what the question is indirectly telling you. If AC is an arc that is part of a circle, what this really means is that AC is part of the circumference of a circle, which means we have a bigger circle that goes like this. And this AC is part of the circumference. So that's what that statement is really telling you. And from that, you can then infer that this is the radius. OA is the radius, because remember, the radius of a circle is a straight line drawn from the center of the circle to the circumference of the circle. So here, this line here is starting from the center because the question has told us that the center is O. So if this is the center and this is part of the circumference of the circle, this OA here, it's a line coming from the center of the circle to the circumference of the circle. So what does that tell us? OA is the radius. OA is the radius. And whenever you have a sector, you always need to have two radiuses, two radii. It's actually radii, not radiuses. Two radii. So what must be the other radius? It must be OC, because we're coming from the center, which is O, and we're touching the circumference again here at C. So OC is also the radius of the sector. The key thing is in understanding what the radius of a circle is. It's a straight line drawn from the center of the circle to the circumference. OC, we're coming from the center. How do we know it's the center? The question tells us it's the center. We're coming from the center and we're touching the circumference, so that's the radius, and that's equal to 5. So, in other words, OA is equal to OC is equal to the radius is equal to 5 centimeters. Okay? That's one thing that you have to observe. OA is equal to OC, and that's equal to 5 centimeters, and that's equal to the radius of the circle. The arc has a length 6 centimeters. The arc has a length 6 centimeters. How do you find the length of an arc? Remember that the length of an arc is equal to the radius of the thingy multiplied by theta. So if the thingy is 6 centimeters, then the first thing you will see is that 6 centimeters is equal to 5 multiplied by theta, which implies that theta is equal to 1.2 radians. Theta is equal to 1.2 radians. All this information here, I am simply getting it from reading the question. See how beautiful maths is? You're already starting to figure things out just by reading the question. So if this is 6 centimeters, if this is the length of the arc, I know that the length of an arc is equal to r times theta. So in other words, that 6 centimeters is equal to r, which is 5 multiplied by theta, so theta is equal to 1.2 radians. I'm simply getting this from reading the question. Find the area of the shaded region. Well, the area of the shaded region is the area of the big triangle minus the area of the sector. Minus the area of the sector. So, I know that now what is the area of the triangle? Well, this is a right angled triangle, so the area is equal to half times the base times the height. The base is 5 and the height is AB. So, the area of the triangle is equal to a half multiplied by 5 multiplied by AB. But I don't know my AB. How do I get my AB? SOHCAHTOA. I use my trigonometry. This angle here that I have found to be 1.2 radians is actually this angle, theta, is actually this angle. Because remember that this angle here that you're finding, it's the angle between the two radii. So if this is one radius and this is the other radius, then this angle theta, this here, is the 1.2. This is the 1.2. This is the 1.2. So the angle here, this is the 1.2. So if I use my trigonometry, my SOHCAHTOA, then I will say tan of this 1.2 is equal to AB over 5, because I want to get AB. So tan of 1.2 is equal to AB over 5, which implies that AB is equal to 12.86 centimeters. That's my AB. My AB is 12.86 centimeters. 5 times tan of 1.2, that is my AB. So therefore, the area of my triangle is equal to a half multiplied by 5 multiplied by 12.86, which is going to give me 32.15. 32.15. So this is the area of my triangle, 32.15. Now what about the area of my sector? What about the area of my sector? Well, the area of the sector is equal to half r squared theta. R is 5, theta is 1.2. Theta is 1.2. So the area of my sector is equal to a half multiplied by 5 squared multiplied by 1.2, which is equal to 15. And my area is the difference between the two areas. So therefore, I'm going to say that the area of my shaded region, it's going to be equal to the 32.15 minus 15, which is going to give me 17.2. And that is my final answer. 17.2 square centimeters. That is going to be my final answer. If I look at the mark scheme for this is question 5, and boom, 32.15 minus 15, 17.2. 17.2. And that's how you get the solution to this question. And that's it. So that brings us to the end of this example on circular problems. If you enjoyed the video, please like the video, subscribe to the channel. So until next time, thank you.